Hello everyone, what I want to do is go over quiz 8. So a lot of people did well, but a lot of other people did really funky things, and even some people who did well, they're doing these problems in a way that if you are a particularly an actuary major and you do this on exam FM, you're guaranteed to fail. So please, eventually you're gonna, either you're gonna have to find another profession or basically learn to do the problems like this the way I'm doing them. And some people just did weird things on this quiz. So, um, and one thing I want to stress before I do anything is that loans and hence mortgages, they're just annuities. You price them as if you would price an annuity. You treat them as if they are an annuity. That's it. Loans and what we're doing now, bonds, are just special cases of annuities. That's it. Obviously, with a loan, you want more relevant information for accounting and tax purposes, like how much interest did you pay in a certain time period, because you can often deduct that from your taxes. What's your outstanding balance after 10 years or whatever, because on your accounting books, that's how much debt you would have, that's how much the loan value is, et cetera, et cetera. All right, so you take out a 25-year, $275,000 mortgage with constant payments at the end of each month, and I-12 is 6%. So let's just focus on this here and ignore everything else for a second. So we have an annuity, basically, 25 years, payments at the end of each month. So there's 300 payment periods. The per period per month interest rate, well, we're given I-12 is 6%. So it's just I-12 over 2. And yeah, I really like to give you fairly easy to work with interest rates. Why not? So 0.06 over 12.005. Okay, so payments are constant at the end of each month. This is my per month interest rate. This is how many periods there are. This is the value of the loan, the value of the annuity. So it's always the present value is the value of the annuity, the value of the loan. 275,000, let's call it K, is going to be K, A300, just a present value formula for an annuity. So and payments are at the end of each period, so we're in annuity immediate mode. So, all right, 275,000, present value, 300, and 0.5 multiplied by 100, 0.5 interest, and we get 1771. 0.8289. That is the payment value for this mortgage. Okay, and you need that because you want to pay 100 less for your new mortgage. You want to refinance to pay $100 less. What's going to be the interest rate corresponding to that? Very practical question. You want to refinance, so you pay $100 less than you normally would, or originally would. What interest rate should you look for? Okay, so first of all, we need now the value of the mortgage when you want to refinance, which is 10 years in. Sorry, this is 15 years in. It's not 10 years in. It's 15 years in. After 15 years, you wish to refinance. So that's going to be, we want the outstanding balance. We want how much this loan is worth. Well, that's going to be 180 months. Oops, sorry about that. Okay, and right, so you can either use the formula for the outstanding balance when you have a constant payment annuity, a constant payment loan with no interest rate changes. That's the quickest way to do it. Or you could just do like we've done, like the very, very always going to work generic formula of you take the accumulated value of the original loan amount after 180 months minus the accumulated value of the payments. Either way, you get the same answer. 8289. This is a little quicker, I think. So, and remember the formula is it's the original loan. How many? No, the original number of payment periods minus, well, what you're looking for, 180. And this is 0.005. So let's see what this is. 1771.8289. Make that negative payment. 120N, 0.5 interest. Compute present value. So this is going to be 159,594,743.6. Now, if you did want to do it the other way, let's just check it. So 275,000 times 1.005 to the 180. Stored in the one position. That is the value of the original loan amount after 15 years, 300 months. Okay, so let's you store that. The easiest thing to do, I think, is to store it in any position. One position is good. Let's find the accumulated value of all the payments. 1771.8289. Payment 0.5 interest 180, and compute future value. Take that plus this amount here, and well, we're off by a penny, but basically it's the same thing. 159,594, 73 versus 74. But, just rounding, we're off by a penny. So yeah, you do different formulas, you will be off by a penny, maybe two, heaven forbid 3. But anyway, and this is just a formula, 300 minus 180, so that's why I plugged in 120. All right, so enough of that. Okay, so now we do a loan reset. So basically, I want to take out a new loan for 159,594 and basically 74 cents. So remember, with all these problems, you're assuming that there's no prepayment penalty. And often there is no prepayment penalty because mortgage companies and banks know that if if you could easily repay the loan quickly, you probably wouldn't have taken the loan out in the first place. So you're often not worried about people repaying it too quickly. But anyway, yeah, so you want to take a loan out for this amount, so you can pay off your original mortgage, you want payments of 1771.83 roughly minus 100. Not very subtle. 1671.8289. Okay. So, right, this is the loan amount you want. These are the payments you want. Let's see what interest rate that corresponds to. The loan amount is the present value of the loan, sorry, mortgage. Well, mortgages obviously are loans. So the mortgage, the present value of the mortgage is the mortgage amount. This is the mortgage amount, 159,594.74 cents. This is the present value, 1671 and roughly 83 cents. Again, it's this here minus 100. These are my original payments here. Well, there's 120. It's a 10-year loan, 10-year mortgage, so it's 120 months. We don't know what the interest rate is, so let's go figure it out. And you really can't do this without a calculator. Sure, you can do an online grapher and do this, but you're not going to have an online grapher when you take exam FM, so just get used to using the calculator. Right? It really isn't hard, and if you didn't purchase the calculator and you're an actuary major, purchase it. It's I think it might be a little more expensive these days than it was, but still like $30. Really nothing compared to the cost of the time cost of studying for exam FM and the actual cost of exam FM. Anyway, all right. So this is the present value, okay? And let's take the person getting the mortgage perspective. So I want 159,594.74. So it's positive. Present value. Payments are 1671.8289. That's how much I'm willing to pay. 120 payment periods. Compute IY, and we get that as a percentage. This is going to be 0.394%. Well, sorry. Calculator always has it as I. Okay. Well, this is the per month rate. Effective. This is the per month effective interest rate. I'm not asking you, I am not, N-O-T, not asking you for the effective monthly rate. I'm asking you for the nominal monthly rate. I'm asking you for I-12. I'm asking you for I-12 corresponding to this new mortgage. So all you do is multiply by 12. Because when I look at 0.394 per month, that doesn't really have a whole hell of a lot of meaning to me. On the other hand, when I look at, and this is a percentage, when I look at 4.73%, well, that has some meaning. I can compare that to other investment strategies, and I can compare that to, other rate of returns, the stock market rate of return, my bank rate of return, whatever, Annual rate of returns are always a good benchmark, and that's why I want I-12, not the I-12 corresponding to this new mortgage, not the effective monthly rate. Put it this way, this is the monthly effective interest rate, and I can't fit interest here, so okay, so that was the answer, 4.73%. All right, so here, this is where I got some really funky answers, and I basically give you all the formulas to do this very easily in the videos. So, if you don't watch the videos, I guess you really can't do this well. And definitely, if I put something like this on the exam, I'm going to maybe make it like a, 20-year and monthly payments, and I want to see the work. But at this point, I want to. If you're going to do it by hand, I don't like you doing it. I don't want you to do it by hand. But if you're going to do it by hand, I want to see the arithmetic for every single payment that you make. The point being, don't do it by hand. That's not what I'm trying to teach you in this course. I'm not paying. I'm not paid to teach you how to do these problems by hand or using a computer. You're supposed to do these problems using formulas that you can easily apply to do these quickly without a computer. That's the point of this course. And if you object to that point, well, that is the course. Don't take the course. No one forced you to take it. So, all right. So we have a formula. So we have a 20-year loan, 6%, effective annual interest, paying off 130% of each year's interest at the end of each year for the first 12 years. So the formula in this situation is the outstanding balance, and this is a formula I don't think was in the book, which is odd, but that's why I gave you the formula in the video. So watch the video and you'll know the formula. It's 1 plus your interest rate minus 130% as a decimal, 1.3 times your interest rate raised to the t. Okay. So this gives you 120,000. 0.982 to the t. Okay, so this is going to be, we'll just plug in t equals 12. Pretty straightforward. And this you get 96,498.18. Okay, so we do a loan reset. This is kind of like my new loan now. And now for the next 8 years, you pay off the loan by paying constant principal at the end of each year. Now, this is, forget about theory of interest, forget about this course. You really, if you're a business major, economics major, actuary major, anything resembling business, banking, or finance, or anything, you absolutely need to understand that when I say you're paying off constant principal, that does not mean you're making constant payments. Each year's payments for a loan, or each period, the payments for a loan consist of interest and principal. Okay? You first pay off the interest. Then what's left, you make towards, if anything is left, you make towards your principal. And that could be negative. You could not, you could make payments that are less than the interest payments. So it's interest plus principal. Now, as you chip away at principal, your interest becomes less and less and less. Okay? So that means if you're paying constant principal, each year you're paying less and less and less interest, so your payments are less and less and less. So they are not constant. So I had quite a few people say, oh, okay, well, principal repaid is constant, so that means we're paying this off with constant payments. No, that's really important to understand. That's just not how mortgages work. That's not how loans work. Constant principal just means, well, you're paying off constant principal and the interest differs each year. It gets smaller and smaller and smaller because your outstanding balance, the amount you're paying interest on, gets lower and lower and lower. And I apologize for kind of repeating the same thing over and over again, but really important concept to understand. Again, not even for this course, but just in general, if you're interested in business. Okay, so for this new loan, we have a formula for payments. KT plus 1 is going to be your outstanding balance divided by the number of payment periods, and that's 8, so 8 years. So obviously, if you're going to pay constant principal each year, well, this is how much principal you're going to be paying. You need to chip away. You need enough principal to add up to your outstanding balance. Okay, so yeah, you're going to make 8 constant payments. Those constant payments have to be. So it's not really relevant to the problem, but the actual amount per year that you're paying. So you're paying $12,062 and 27 cents in principal at the end of each year, and that makes sense. Times it by 8, you get your loan amount, and you don't owe any more money. Okay, so this is the amount of principal you're paying off each period. But you have interest, and the formula for interest essentially, I didn't really, just the formula in general is, yeah, you just take this amount here, 96498. And I did get sorry, I probably should have put more decimals here, but I'm running out of room, so glad I didn't. Yeah, the formula is it's your interest rate times your outstanding balance at the beginning, or the loan amount at the beginning, rather. We're doing a loan reset. So this is my loan amount at the beginning times 1 minus T over the number of payment periods. So some people got this using really weird methods. Okay, I guess. But you really don't want to see an amortization table for 20 periods. And again, from now on, if you want to do that, great. I want to see by hand every single arithmetic that you do, because I don't want you to do that. Like, that's a grotesquely inefficient way to do that. And again, if you're complaining, well, this is ridiculous because a computer can do this. Well, yeah, I'm not arguing that. And if you're an actuary, you're going to use computers. You're not going to do this on the job, but the point is, the Society of Actuaries and the Casualty Actuary Society, they want you to understand how the hell loans and annuities work. That's the same thing. I want you to understand how they work. So I don't want you to just do things by hand. We have nice formulas that are useful. And I always encourage people, if I don't derive a formula, derive it. I think it's always a fun challenge. I'm a pure mathematician. That's my career. I always think it's fun to rederive, formulas, and you often get a better understanding of, how things work when you rederive things. All right, anyway, sorry about that. So here, T is, of course, 7. 8 is 7 plus 1. So just dump in 7. And this is your very last payment, $12,786. Okay. So it's actually pretty close to, yeah, so this actually is pretty close to the amount of principal you're paying at the end of each year. So just curious how much interest what's the last interest payment? Well, about $723 is your last interest payment. All right, well, yeah, that takes care of it. Um, so, all right, well, good luck on the quiz today. And yeah, so long, take care. Bye bye.